All right, so yesterday we talked about the volumes of cylinders and prisms. We said that the formula for the volume of a prism was what? Base area times height, right? Capital B times H, where the capital B stands for the base area. Specifically for a rectangular prism, it's what? Good. Length times width times height, because the base area would be length times width. And then we did the the volume. We did the area and the volume, but we said we would come back to the cylinder. Volume is base area, and the area is a circle, so it's pi r squared h. And then we talked about similar volume or similar solids. If I'm looking at the ratio of the side or the radii or the scale factor, if that's like A to B, then the ratio of the areas would be A squared to B squared, and the ratio of the volumes would be A cube to B cube. So number 1 says to find the volume of the solid with a regular pentagonal base. So in this case, the base is obviously the pentagons, which are at the front and the back. My formula is the base area times the height. The B is the area of a pentagon. How do you find the area of a pentagon? Yeah. 1/2 ANS, right? So A stands for the apothem, which is given. That's 10. How many sides are in a pentagon? 5. And the length of each side, which is actually back here, that 14.5, would be any of those side lengths. And then I just multiply that out. So I could do 1/2 of 10, or I could multiply it all out and divide by 2 at the end. Either way, I get the base area, 362.5. And then for the volume, I take and multiply that times the height. And the height is the 15, which is the segment that connects the two bases. 5,437.5, and this time it gives it to you in inches, and it would be inches cubed. Raise your hand if you got it right. Really? That's scary. What was the holdup? Okay. Do we understand it now? Yeah? Okay. All right, 2, find the volume of a right triangular prism with a height of 32 inches, a base height of 12, and a base length of 18. So if the base is a right triangular prism, it would look something like this. It says that the height of the actual prism, which would be one of these segments, the ones that connect the two triangles, is 32. And it says that the base height is 12 and the base length is 18. Where you put those doesn't really matter, but the fact that it's a right triangle tells us obviously that's the base and the height to do the area as 1/2 base times height. So volume equals base area times the height. In this case, the base is a right triangle, so this would be 1/2 18 times 12. So the base area, or capital B, is 108. And then the height of the prism is 32. 3,456 inches cubed. Raise your hand if you got that one right. Okay, better. Questions? Yep. It would have to be either equiangular, equilateral, where you would use your 1/2 ANS, but your special right triangle, or it will be a right. It's going to be one of those two. Like an oblique or like an obtuse. No, it'll be something that you could figure out. Santi.
Why do not include the height on this one?
The height of what?
Like the 12.
We included it in the area of the base. We included it there. So the height, that's.
Why not multiply by 32?
I did. That's here.
Oh.
Yeah. So we did the area on the bottom first, and then we found the volume. All right, 3 says find the volume of a right cylinder with a height of 30 feet and a diameter of 14. So if the volume of a cylinder is pi r squared h, obviously I know pi. What is r? 7. I have to cut that diameter in half, and then the height is 30. So this would be 49 times 30 times pi. If kept exact, so you'll look at your answer choices on the test and see, is it kept exact? And if it is, that's what it would look like. And if it's rounded, it would be that 1470 times pi. 4,618.14, and both of these would be feet cubed. But you just got to pay attention. I would say keep it exact as long as you can, and then look at your answer choices. Are they exact? If they are, that's it. If they're not, then you're going to have to round it to whatever it's rounded to. Questions on that one? All right, this one says a cylindrical beaker with a diameter of 10 inches and a height of 12 inches is filled with water and then poured into a rectangular pan that's 14 inches by 9 inches by 3 inches. What's the volume of each solid? Would the water overflow the pan? If so, what is the height of the water in the beaker after the pan is filled? So I've got obviously the cylindrical beaker, right? And then I've got a rectangular prism as a pan. So the first thing I want to find is the volume of each. So this one is going to be pi r squared h. And this one could be length times width times height. So for the cylindrical beaker, the diameter is 10, which means my radius is what? 5. So this would be pi times 5 squared times the height, which is 12. Or 25 times 12 times pi. And you can, again, keep that exact. Or you can multiply it all out. So 300 pi is how we'll keep it for now. Actually, no, we want to compare it without pi. So we're going to multiply it out. 300 pi would be 942.5477 repeated. But 942.5, and that would be cubic inches. And then the volume of the rectangular pan is 4 by 9 by 3, or 14. 14 by 9 by 3. So 378. That's the first part. Here's the volume of the cylinder. Here's the volume of the pan. Would the water overflow the pan if I poured from it? Yes, obviously. Why? It's more than, right? So then what's the height of the water in the beaker after the pan is filled? How do you figure that out? Yeah. What is it? 564. Oh, wait, but I didn't round it. The same. 942.5 minus 378 is 564.5. You're fine. I just rounded it to the nearest 10. So that's how much is left in this cylinder. That's the volume that's left, right? So the volume is 564.5. The pi stays the same. The radius didn't change. The radius is still 5. The height is what we're trying to find. Okay, so 25 pi on 564.5 divided by 25 pi gives me h is 7.187. So it would be 7.2 if we're rounding to the nearest tenth. Good job. This is a great standardized test question, by the way. You are going to get word problems on your test. I don't know that they're that complicated, but there are going to be application word problems. There's a couple of them. So you got to be prepared to answer it. But, yeah. Because it's only, so like once you pour the water out of the beaker, you're trying to find out what would be left in that beaker to figure out how much height there is. So if I took the 900 or 942.5 cubic inches and I poured it in and I got 378 of them in the pan, to find what's left, I would subtract. So this 564.5 represents how much is left in the beaker after I poured out what's within the rectangular pan. So then that's the volume. The radius of the beaker doesn't change. What did change is the height. So when we plug it in here, the volume is the 564.5 Pi doesn't change. The radius didn't change. The height is what changed because there's less in that beaker. And then you just work backwards to solve for h. Yeah.
It didn't specify what decimal point.
Correct. Right. So like on your, I mean, it's all multiple choice. So if you just look at your answers, you'll see what to round to. Yeah. Other questions? All right. We're going to move into 11.6, which is volume of the pyramids. This is going to be the last thing that's covered on this week's test. So your test is Friday. I am actually going on Grad Bash, and we were supposed to be meeting later, and I was going to come and give you your test, and now we're meeting earlier. So you are going to Miss Corey's classroom on Friday. Miss Corey's classroom is 113. She's the other geometry honors teacher. She is going to give you your test, okay? So she is also giving it to her A period. Like she will have already given it once. She'll have already known about timing and all the stuff. She's the best person to give it, okay? You will go to room 113 on Friday. I'm going to say it every day this week, but then hopefully you'll remember. You're going to go to 113. You're going there. Her kids are coming here with the sub, okay? So the regular pyramid has one base that's a regular polygon. So if it's a quadrilateral, it's a square. If it's a pentagon, it'd be a regular pentagon, a regular hexagon, a regular triangle, which would be an equilateral triangle, okay? The lateral edges are all congruent. The lateral faces are congruent isosceles triangles, and the altitude meets the base at its center. It looks like this, okay? So this would be a square pyramid. The base has four sides and it's regular, which means it would be a square, okay? So not only is the base regular, but it said the sides were also all equal isosceles triangles. So there are four lateral faces, which are triangles, and they are all isosceles triangles because the lateral edges are all congruent. The base edge does not have to match, but the rest of it does. The volume of a pyramid, no matter what the pyramid is 1/3 base area times height. Think it would be less than a bit, like if I had a square box, right? If I had a cube and I wanted the volume, that's base area times height. If it's a pyramid, you're taking away some of that space, so it should be less than. That's why we multiply it by 1/3. It is specifically 1/3 its size, okay? But it is less than. So I always think a pyramid would be smaller than a prism with the same dimensions, which means the volume is going to be less than, and that helps me remember the 1/3 part. So you're going to find the area of the base. Again, it would be a regular polygon, and then you're multiply it times the height. The height this time is your altitude. So it is going to be a segment that goes from the vertex, which is at the top, to the base, and it's going to form a right angle. So you'll see a little right angle mark there to show that it's hitting at its direct center. No, so that's called slant height, and it won't, because this actually forms, which we need that when we do surface area, not volume, so don't let it hang you up too much. But this would actually form a right triangle. The height is one of the legs of the right triangle. The base of that right triangle is actually half the side of the base of the square. And then this is what's called slant height, and it would be the longest side there. There's a bunch actually happening here. It gets complicated when we get into surface area. The good news is we're not there yet. You mean like here? Yeah. So this is your lateral edge. That's the lateral edge. This is half the base edge. And then this would be called slant height. But we're going to worry about that when we get to area. You don't need that measurement for the volume. The volume is just regular height. All right, so it says a regular square pyramid has a base edge of 6 centimeters and a height of 12 centimeters. Find its volume. If you're a visual person and you want to draw it out, I tend to start with the front triangle. And then I work my way backwards. So if you want to draw it out, you can. You don't have to. because it gives you everything you need.
So the base is just the base, right?
It's the edge, yeah, like the side of the base. So 1/3 base area times the height. The area of the base this time is a square. 6 and 6, so it'd be 36. Good, Santi. 36. And then the height is 12. So 1/3 of 36 is actually 12, and 12 times 12 is 144 centimeters cubed. Notice it says give the exact answer. Okay, this time there was no rounding, but if there was, you would have kept it exact. So like if it was 144 over 3, you would keep it as 144 over 3 instead of converting it into its decimal. Yeah.
It's a square. I thought that for a square it's the side length of the cube.
No. That's if it's a cube.
Okay, so
Yeah.
Square, it's like.
All right, example 2 says find the volume of the triangular pyramid. So I know volume equals 1/3 base area times height, but the base, the B, is what we got to figure out. In this diagram, if you look at that triangle on the bottom, if it's a regular triangle, what kind of triangle is it? Even more than that, right? It would be? What's regular mean? All 3 sides the same. So what kind of triangle is that? Equilateral. So the 4 that they give you on the front would also be the 4 on the slanted on both sides. So if I had just look at the base on this pyramid, it's a 4, 4, 4 equilateral triangle. Then it gives you the actual measurement that is the height in here. The height of the base is 3. So it already gives you everything you need to know, but it doesn't have to. It does not have to give you that height because you know 1/2 ANS. Yeah. It's a regular, they are all regular pyramids, and regular means all the sides are the same. They're always the same. Yep. So if it's a regular with 4 sides, it's going to be a square. If it's a regular with 3 sides, it's going to be equilateral triangle. Yep.
Does that mean you can't have a rectangular triangle?
You mean a rectangular pyramid? Mm-mm. Okay, not with the regular ones. All right, so now my base area would be 1/2 base, which is 4, height of the triangle on the base, which is 3. So this is 6. Your base area is 6. 1/3 times 6 times what's the height of the pyramid?
14.
That's the volume.
It's 14.
Oh, so this actually shouldn't say find the volume. Sorry, you're looking for the height.
Yeah.
The height is what?
Kind of threw me off there.
So sorry.
The volume's 14, so it'd be 14 equals that.
Good. The height is what we're missing. This equals 14. Yep. Yeah.
14 times 3. Or multiply the whole thing by 3 on both sides.
I would actually do this because you can simplify it, right? Doesn't mean what you're doing is wrong. But 2h, and then I would divide by 2. But you could you could multiply by 3 and then divide by 6. It doesn't matter how you do that.
I think the second one's easier.
Questions on that one? All right, example 3, find the height of the triangular pyramid. So this is like what we just did. See if you could do it by yourself. All right, so what's the formula for the volume? He's got it. Yeah. So volume equals.
So obviously you would do 24.
Give me the formula for the volume of a pyramid first. Thank you. Okay, so now you're gonna do the base area first. Okay.
So you see that the volume is 24, it says?
Yeah.
24 equals 1/3.
Yep.
And then the base do 6 times 3 divided by 2?
You can. You could do a half of 6 and then multiply times 3. You could do that in any order you want, but it's 1/2 base times height. Which is?
9.
Good. And then?
Parentheses h.
Good. Then what?
1/3 times 9 is 3. Then 24 divided by 3 equals height,
Which is?
which is 8.
Good. Questions on that one? All right. Now we're back to the volume of similar solids. So we talked about this yesterday. Remember the ratio, if the scale factor is a to b, the areas, we would square them. So it'd be a squared to b squared. And the volumes, we would cube them. So it'd be a cubed to b cubed. Because the pyramid is a solid, if they are similar pyramids, the same rule applies.
So I have the answer.
Okay, tell me how you did it. So it says, obviously it says they're similar. Find the volume of pyramid B.
So I did the big pyramid to the smaller pyramid for the scale factor.
Okay, so you did 8 to 6, and then simplified it, right?
Yeah, cube.
4/3. That would be the scale factor, or obviously the ratio of the heights. Then to get the volumes, you cube them. So 64/27 is the ratio of the volume of the big one to the volume of the small one. And then which one do you have?
These three go to 96 over x.
Good. The big one would be 96. The small one is what we don't know. So then I can cross multiply 27 times 96. 2,592 equals 64x. And then divide by 64. And x equals 40.5. It would be meters cubed.
Where did we get that 4 over 3 cubed?
The ratio of the heights. So he went A to B. You could have done B to A, just you would have flipped both sides of this, which is fine. But 8 to 6, you want to then reduce it. Otherwise, you're dealing with huge numbers. So if I reduce 8 to 6, it becomes 4 to 3. That's the ratio of the sides or the scale factor. So then to get to the ratio of the volumes, you've got to cube each individually one.
But we still get the same answer.
If you left it as 8,
Yeah.
yeah, as long as you cubed it.
But on this test, will we be able to use our calculator?
Yep.
Oh, okay.
Questions on that one?
Wait.
All right, last one is a composite solid again. So obviously we saw those yesterday with the prisms and the cylinders, and then you can see them also with your pyramids. So if I want to find the volume of this, I have to add those two shapes together, okay? The bottom part of this shape is what?
Square.
It's a square, it's a cube or a square prism or a rectangular prism, okay? The top is,
So it's not a pyramid.
the top is a square pyramid. Good. So if I want to find the area or the volume of the cube on the bottom, 6 cubed or 6 times 6 times 6. Yep.
How do you know what the difference between a cube and a square is?
Because a square is just 2 dimensions.
Square is 2
A cube is 3 dimensions. So I get 216 for the volume of the bottom of this guy. And then I want to find the volume of the top, 1/3 base area times height. Which shape is my base? It's a square. The sides are 6.
36 squared is 36 for the base.
Good. And the height is also 6. 1/3 of 36, or 1/3 of 6, you could do either one. This would be 12 times 6, which is 72. And then I add the 72 and the 216, and I get 288 meters cubed. Questions? Any questions on last night's homework?
Ew.